Hey guys, all right, so today we're going to talk about angle measures of polygons. So starting with your warm-up, okay, so what are we trying to learn here? What is our objective? So our lesson question is, what is the relationship between the angle measures of triangles and other polygons? So then our lesson goals are going to be to analyze the relationship between angle measures and a triangle and other polygons. So we're going to take a look at identifying polygons, proving the exterior angle sum theorems and the interior angle sum theorems, and being able to calculate the measures of angles. Okay, so starting with our vocab, important words to know. Okay, so first we have concave polygon. Okay, so in the name, we have the word concave. So think about concave as caving inward. Okay, so like here, this side of the polygon caves inward. All right, so this is a polygon in which the extension of at least one side contains a point inside the polygon. See how this point here is right inside the polygon, that point there. Okay, so that's what it means, is that there's at least one point inside. So it's somewhere in the figure, it caves in. Okay, that's a concave polygon. All right, next we have a convex polygon. Okay, which is a polygon in which every line segment connecting any 2 points on the polygon contains no points outside the polygon. Okay, so that's basically saying that if I'm trying to connect 2 points, so like this point and this point here, okay, when I connect those, I'm just tracing a side of the figure already. Whereas here in the concave polygon, see how if I tried to connect this point and that point, I create that line there. Okay, so it skips that point. So that's how they're different. Okay, so basically the convex does not cave in. Okay, the concave does cave in. All right, so then next we have exterior angle. And the exterior angles are created by extending the sides of our polygon. Okay, so see how that side of the pentagon here is extended? That exterior angle that's created on the outside, that's what we're talking about there. Okay, exterior angle, so the angle on the outside of our shape. Okay, so an angle formed by a side of a figure and an extension of a side adjacent to. So remember, adjacent just means right next to. So we have an angle here and an angle there. So those are adjacent angles. So we're just extending our side. Okay, next we have polygon. Okay, so a polygon in a plane is a closed figure formed from 3 or more line segments such that each segment intersects exactly 2 other segments, one at each endpoint, and no segments with a common endpoint are collinear. Okay, so main thing there is that it's a closed figure formed from 3 or more line segments. Okay, so 3 or more sides, basically, a shape with 3 or more sides. Okay. All right, so then we have a regular polygon, and anytime you see the word regular in front of a shape, that just means that all of the angles are equal and the sides are equal. And that's what equiangular means, which is just a really funny word for equal angles. Okay, and then equilateral just means that all the sides are equal. Okay, so equal angles and equal sides. So basically in this triangle, all 3 angles are exactly the same. So if we wanted to figure that out, well, we already know that the interior angles of a triangle add up to 180, right? So if we divided 180 by 3, we would get 60. So each angle in an equiangular, equilateral triangle are 60 degrees. Okay, that's a mouthful. All right, same thing with a square. Okay, we know that the interior angles of a square add up to 360, and we know that all of the angles and sides are congruent in a square. So then 360 divided by 4 gives us 90. Okay, same on all these. So basically, anytime you see that regular in front of a shape, that means all the angles are equal and all the sides are equal. So pentagon, hexagon, octagon. Okay, those are all examples of regular polygons. Okay, now we can have pentagons that aren't regular. Same with hexagons, same with octagons, but just a plain old regular polygon. Everything is congruent. All right. Okay, so what is the relationship between the angle measures of triangles and other polygons? Okay, and this is just a little table to give you a visual. So a triangle has 3 sides, quadrilateral has 4, and quad, that prefix tells us how many. Quad means 4, so 4 sides. Pentagon, pent, means 5, so 5 sides. Hexagon, hex, means 6. On a heptagon, hept, means 7. Octagon, oct, means 8. Kind of like an octopus has 8 legs, okay? A nonagon, that's 9. So non means 9. And then decagon. So dec or deca means 10. Okay. All right, moving on. Okay, angles and polygons. So we can work out the angle sum of any polygon by splitting it into triangles. Okay, any polygon, we can cut it into triangles. So remember that the angles in a triangle equal 180 degrees. Okay, so like in our triangle here, we know triangle is 180. So with a quadrilateral with 4 sides, we can draw the diagonal down the middle and we get 2 triangles. Okay, so then 2 times 180 tells us that the interior angles of a quad add up to 360. Okay, pentagon, we have 5 sides and we can cut it into 3 triangles. Okay, so triangle there, there, and there. So 3 times 180 gives us that a pentagon's interior angles add up to 540 degrees. Okay, same with the hexagon. Hexagon, we can cut it into 4 triangles. So 4 times 180, 720 degrees for the interior angles of a hexagon. And so on and so forth. You get the idea. Okay, so the heptagon has 5. The octagon makes 6 triangles. Okay, so then if you look at the pattern, we're able to come up with our formula for figuring out the interior angles. Okay, so if the polygon has not in sides, okay, so in sides, so in is just representing the number of sides, okay, in equals number of sides. Okay, so there will be n minus 2 triangles inside. So like a pentagon has 5 sides, right? So 5 minus 2, boom, 3. Same with an octagon. Octagon has 8 sides. 8 minus 2, 6. Okay, so that tells you how many triangles are inside. So then to get the interior angle sum, the formula becomes n minus 2 times 180. Or we could also write that as 180 times n minus 2. Okay, doesn't matter which way we write it. It equals the same thing. Okay. All right. So the next, we have our chart here with our sum of interior angles. Okay, so starting with the triangle, triangle has 3 sides. So then if we were to do n minus 2, okay, 3 minus 2 is 1. 1 times 180 gives us 180, right? Which is what they have there, okay? But I just used it. 1 times 180 equals 180 degrees, okay? That's a triangle. So then we have our each angle here. Well, all 3 add to 180 degrees. Divide by 3, then each angle is 60 degrees. Okay. So the next, we have the quadrilateral. Okay. Quadrilateral has 4 sides. So then n minus 2, so 4 minus 2 is 2. And then 2 times 180 gives us that 360 degrees. okay? So then if we take that 360, divide by our number of sides, that gives us 90 degrees. Okay, next we have the pentagon, same thing, okay? 5 sides, so then n minus 2 gives us 3. So 3 times 180 gives us that 540. Okay, then we take that 540, divide by n, which is again our number of sides, so divide by 5, and that gives us 108. Okay, making sense? Following me? All right, so then hexagon, same thing. Okay, 6 sides, so n minus 2 gives us 4. 4 times 180 gives us that 720. 720 divided by n, which in this case was 6, gives us the 120. So on and so forth, with 7, with 8, and so on. Okay, I'm just going to move this over here and clear this out. Okay, so you'll notice that this works with any polygon, okay, using your n. So it's just n minus 2 times 180. And then once you have that answer, see, n minus 2 times 180, same thing. You just divide by n, okay? So just like we did on all of these. Does that make sense? I hope. Okay. Move this back. All right, so then angle measures of polygons. Okay, so what we just did was proved and showed an example of the polygon interior angle sum theorem. Okay, so the polygon interior angle sum theorem just states that the sum of the measures of the interior angles of any n-gon, okay, so you can insert any number there for n, is 180 times n minus 2. So this formula will work for any n-gon, any polygon, okay? Where n is the number of sides of the polygon. So that's just what I was showing you just a second ago, okay? So then what is the sum of the measures of the interior angles of a pentagon? Okay, so a pentagon has 5 sides, so n equals 5. So then inserting it into our formula from here, 180 times n, which was 5 minus 2. Okay, so then 5 minus 2 is 3, times 180, 540 degrees. Okay, all right, moving on. Okay, using the polygon interior angle sum theorem. Okay, so here we have, what is the measure of angle K? So this angle here. All right, so first we need to find the sum of all of the interior angles. Okay, so we have 180 times n minus 2, which is our formula. N in this case is 6 because we have 6 sides. Okay, so then n is 6. So if we insert 6 here, 6 minus 2 is 4. 180 times 4 gives us 720. Okay, so that's our first step. So finding the interior angles. Okay, the sum, I should say. Then we want to find the sum of the angle measures that we already know. Okay, so we know this is going to be our grand total. So we want to know what we already have. Okay, so 106 plus 115 plus 154 plus 90 plus 107. Okay, because remember that little square tells us that is a 90-degree angle. Okay, so then if we add all of those up, that's 572. So then step 3 is to subtract 720 minus 572, which tells us that angle K is 148 degrees. Okay. All right, moving on. Next, we have angle measures of polygons. So another example. Okay, so what is the measure of angle B of our pentagon? Okay, so it just told us this is indeed a pentagon. So it has 5 sides, and we could just count the sides. 1, 2, 3, 4, 5. Okay, so then using our formula, 180 times n minus 2, n in this case is 5. So 180 times 5 minus 2, which becomes 180 times 3. Okay, which is then, and I'm going to use this so I can type. Okay, 180 times 3 gives us 540 degrees. Okay. So then that's how much our interior angles add up to. That's the sum of the interior angles. Okay. Now we need to know the sum of the angles that we already have because we are looking for angle B. Okay, so then add up what we already know. Get my tool here. Okay, so 89, 98, 150, and 92. And that's going to give us 429. Okay, so then last step, we take our total amount, 540 degrees, minus what we already know. And that tells us that our missing angle is 111 degrees. Okay, so B is 111. Okay. All right, moving on. Next we have, what type of polygon is it? Okay, so applying the polygon interior angle sum theorem. All right, so now an interior angle of a regular polygon has a measure of 120 degrees. What type of polygon is it? So we're working backwards. They're telling us what the interior angle measure is. Okay, it's 120 degrees. So basically, we're going to take our formula and set it equal to 120 degrees. So we have our 180 times n minus 2, and then remember we divide by n to figure out each of the interior angles. Okay. So then, first step, okay, we need to get rid of the n. And let me clear this so that you can see what I'm doing here. Okay, so we have to get rid of the n on the bottom. So we're going to multiply by n, because remember here we're dividing by n, so we have to do the opposite to move it to the other side. Okay, I'm going to draw my line down the middle. Okay, so we need to move the n, so multiply by n on this side. And then what you do to one side, you have to do to the other side. So that leaves us with 180 times n minus 2 equals 120n. Okay, next, we need to distribute the 180 inside the parentheses, right? So distribute our 180 inside, so 180 times n, and then 180 times negative 2. And that's going to give us 180n minus 360 equals 120n. Okay, and again, we're trying to solve for n. Okay, so at this point, it's going to skip a couple of steps. So let me move this down to show you. Okay, so we want to, there we go, get the ends together, right? And we want to move this to that side. So it's going to do it all in one swoop. Okay, so we're going to have plus 360 on that side, so that that goes away. So then over here, plus 360, okay, because I can't combine these. There's no n attached here, so I can't put it below. I'm not combining that. This is plus 360 over here. Okay, then I need to move this 120 in to the other side, right? So then since it is positive, I need to do the opposite. So subtract 120 in so that these cancel here. What you do to one side, you have to do to the other side. So 120 in there. And that's going to leave us with 180 in minus 120 in. So there's my step there, equals 360. Okay, because they kind of did it all in one swoop. So then they're just repeating my step here. So I'm just going to come on down. Okay, so 180 in minus 120 in leaves us with 60 in equals 360. And then we are multiplying, so we have to divide by 60. And once we do that, the 60s cancel. And it leaves us 360. Let me move this. There we go. There we go. That kind of lined us back up. Okay, so 360 divided by 60, which gives us n equals 6. Sorry about that. Okay, so n equals 6. All right. Hopefully you could see that clearly. Sorry, got a little muddy there. All right. Next we have polygon exterior angle sum theorem, which states the sum of the measures of the exterior angles of a convex polygon, one at each vertex, is 360 degrees. Okay, so what is the measure of each exterior angle in a regular pentagon? All right, so there are two different ways that we can determine this. Okay, because we're looking at the measures of the exterior angles. So again, to create an exterior angle, we are just extending the sides of our polygon. And in this case, it is a pentagon. Okay, so just extending those sides. So then our first method is that there are 5 congruent exterior angles. Okay, so those 5 exterior angles are here. We have this exterior angle, exterior angle, exterior, exterior, exterior. Okay, so they're all on the outside. Since we have those 5 exterior angles, and we know that they add to 360 because it told us here in the theorem that they exterior angle sum to 360 degrees. Okay, so then we can take that 360 and divide by 5 because that's how many sides we have. And that tells us that each exterior angle must be 72 degrees. Okay, so all of those are 72, 72, 72. Okay, all the way around. All right, so that's the first way of doing it. Then, if we look at the second method, we can use linear pairs. So I'm just going to clear this out. Okay, so here, the linear pair is showing you that this exterior angle plus the interior angle is 180 degrees. They are creating that straight line. And let me just redo that. Okay, so just to show you again, here is the line extending our side. Okay, then we have angle 1, and we have this angle here. Okay, ignore that 180. That 180 degrees is talking about the whole linear pair. Okay, angle 1 plus this angle here is 180 degrees. They create this line. Okay, and that's what a linear pair is 2 angles that add up to 180 degrees. So a linear pair is just like being supplementary. Okay. All right, so then knowing that and using our linear pairs, we can do 540 because we know that's the interior angles, okay, because we use our formula that we just learned, n minus 2 times 180 divided by n, okay, and I'm going to do it this way, okay, that tells us the interior angles, and since this is a pentagon, if we put a 5 in there, that's going to give us 540 degrees. Okay, so that's where that 540 came from. That's the interior angle. So each of these is going to be 108 because we would take that 540 and divide by 5. Okay, so that's where we're getting our 108 from. So that's each of the interior angles. So then if we know that this angle here is 108 degrees, we can figure out angle 1 through subtraction. Okay, because then, let me move that over. Okay, each interior angle has a measure of 108, so using linear pairs, we can subtract. So 180 minus 108 tells us that this exterior angle here is 72 degrees, which we knew from our first method. Okay, so 2 different ways to go about that. I personally think that the first method is way easier, but it's up to you which one you would like to use. Okay, all right, moving on. We're going to prove the polygon exterior angle sum theorem. Okay, so I just went ahead and filled it in for you, so I'm just going to walk you through it. So given a convex n-gon, prove that the sum of the measures of the exterior angles is the sum of the measure of the exterior angles is 360 degrees. Okay, so it wants us to complete the missing parts. Okay, so for a convex n-gon, interior and exterior angles form adjacent angles. Okay, so basically meaning that the angles are right next to each other. So I'm just going to draw an example of that. Let me see if I can just have, here we go. I'm going to use this. Okay, so interior, let's see, here we go. Okay, so interior and exterior angles form adjacent angles. So if I were to extend my sides, okay, the interior, let me switch colors. Okay, the interior and the exterior angles would be considered adjacent angles. Okay, because they're right next to each other. All right, so whose measures sum to 180 degrees. So my pink angle plus my yellow angle equals 180 degrees. They form that straight line there, going right there. Okay, so they form a straight line. Okay, so 180 degrees. So then, because we have an n-gon, the sum of the measures of these linear pairs, one exterior angle at each vertex is 180 times n degrees. Okay. So then the sum of the measures of the interior angles is 180 times n minus 2 by the polygon interior angle sum theorem. So then to find the measure of the exterior angles, we can subtract the sum of the measures of the interior angles from the sum of the measures of the linear pairs. Therefore, we have 180n minus 180 times n minus 2, which is equal to 360 degrees. Okay, so that's just putting into words what we just got done working through in the previous slides. Okay. All right. So then just a reminder to check your email 3 times a day. Make sure to also watch the videos from Edgenuity. They will help you complete the assignments and quizzes. Okay, so don't just watch this one, also watch those as well. And you will have a video from your Northside geometry teachers for every section and unit. If you have any questions, please email your teachers. All of our emails are listed there. We are always happy to help you. Okay, so please let us know if you need more help.